One more example from section 1.7 about function notation and graphing. On the last video, I graphed for you a linear equation. It was f of x equals 2x plus 5. And to be honest, I didn't do quite a good enough job in explaining how to graph that because we just assumed that it was linear. However, not all graphs in this class are going to be linear. There's going to be all types of curves. Now, maybe what is best, maybe what I would recommend, once you get the hang of function notation, is to make a t-table for your ordered pairs that you're going to plot for your particular graph. Now again, what I'm circling, that's the domain. Those are the x values. But what I would recommend then is it says x can be anything between -2 and 3, including -2. So I'd make a little t-table. And let's use just the integers, -2, -1, 0, 1, 2. And I'm going to put 3 in here, but I'm going to put a star by it because it's strictly less than. That means 3 is not included in this graph. Now, all I need to do is take each x value and plug it in to my function, which says x squared minus 2. So the first one I'm going to put in, -2. -2 squared we all know is 4. Take away 4 gives us an output or a y value of 0. So -2, 0 should be on my graph, and it's a closed dot because of this symbol that I'm circling. Let's try -1. -1 squared is 1, minus 4 is -3. So -1, -3 is somewhere down here. If I plug 0 in for x, 0 squared is 0, minus 4 is -4. So 0, and I go down to, on my graph, I go down to -4. If x is 1, the value of my function, 1 squared is 1, minus 4 is -3. So at 1, I go down to -3 again. At 2, 2 squared is 4, take away 4 is 0. So at 2, the value of my function is 0. And finally, 3, which is the point that's not included, but it is the end point of my graph. 3 squared is 9, minus 4 is 5. So therefore, the point 3, 5 is my end point, so I use an open circle there. And now I connect my dots, and there is the graph of the function x squared minus 4. And that is how I recommend that you go about solving and graphing problems where there is a domain such as the one that is given with a certain inequality. Now, what is the range of this particular problem? Again, how far down does the graph go? Well, it gets all the way down to -4, and that point is included since it's solid, so it's less than or equal to y. And how high does the graph go? Well, it gets up to 5, but that point's not included since the dot is open. So therefore, this would be the range of my particular graph.